Hi, welcome back again. Thank you for joining me here. This is just a mini introductory part 2 section where I'm going to show you sample the questions that, should you decide to go with me, I'll show you how we follow along, how we use the reference table, look at the question, I'll read it with you, and we put in that kind of time. That's going to give you the training you're going to need to go forward, okay? So I just want to say one thing. As you do decide to pick and choose what lessons and Regents, there is a small cost on that, and I've made it affordable because, just to give you an example, everyone needs a break, right? And I go to a movie now and then, right, like everyone else, and I go to see a movie, and half the time they're not that good. I feel like I wasted my money. But in any case, I see a lot of young people at the theater running around with their friends, having a great time, and it's $15 to $16 per movie ticket. Then we add everybody's buying Slurpees, slushies, Cokes or something, and then tubs of popcorn, $12, $15. So the average teen person at a movie theater is spending, $22, $25. So, and that's just for that one night, that one movie, and then half the time, you didn't like it anyway, you didn't even pay attention because you're texting on your phone during the movie. But long story short, I'm giving you something here that's going to help your future grade. It's important, and I have it at a reasonable cost, just like going to a movie. So I hope that's of use to you. And once again, feel free. The books are there. If you feel you shouldn't have to pay for anything, God bless. There are some great lessons online, I repeat, but it's all on you. You're going to have to go through it, okay? So I'm giving you something. I'm giving you the years of experience, and I'm going to show you not only the right answers, but I'm also going to sometimes show you why are some answers wrong and how maybe that question would be right if asked another way in using that answer. So that's all part of training, okay? Without further ado, let's move on. I'm going to get the camera set. Let's go forward. Glasses on. Looking forward to training you. Bye. Okay, let's carry on here. Earth Science Review. So here we have, right here, Earth Science Reference Table. So if you don't have yours handy, all right, we have this one here. But once again, I always recommend have it. Here we're doing a Regents from 2019. I'm going to handpick several questions just to show you some of the things, you need to watch for, okay? So let's just get to it. I'm going to cut a couple of pages in. Here's a fun little one. Here's a fun question, and it has to do with that topic you've probably hated in class. It has to do with dew point and relative humidity, and most students couldn't stand it. But let's just make sure we have a good understanding of that one. Question 10. What is the dew point if the dry bulb temperature is 18 degrees and the relative humidity 64%? Well, you have to do a little digging here. So, like I say, a lot of the Regents is going to reflect your reference table. So always be a little unsure of something, get right to the table. And practice will dictate that. You'll know from practice where to go. So let's just find, where is it here? There it is, okay. Okay, we have a dew point, relative humidity. So what's the given, once again? We have an 18 degrees Celsius here for dry bulb. Okay, and if you notice on the table, we have dry bulb twice. Both columns, okay? And we also have relative humidity at 64. So let's start with those two together. Here's the relative humidity chart. There's my 18 dry. And there's my humidity at 64, okay? But is that telling me anything? That's not giving me dew point. Dew point's up here, right? So I have to extrapolate. I have to find a way to get to it. So I'm going to use what I've given, 18. I've got 64 as my percent relative humidity. So I'm just going to go up here. I'm just going to shoot up top of this column and see that 4. Well, it also says that's the difference between wet and dry temperature, isn't it? 4. Okay, but we're not quite done. So let's use that. Let's go up here to 18. And I'm going to use that 4 now. I'm going to count over. 1, 2, 3, 4. See, here's the difference. So I don't just take, one mistake could be you take 18 minus 4 and you get 12. Now, I don't see that in the answer, but that would be a trick way to put it. But anyway, 18, right? 18. I go over 4, 1, 2, 3. Excuse me, I go up here, 1, 2, 3, 4. Okay, and I come down the column, and I have a difference between wet and dry of 11 degrees Celsius. Okay, Answer is number 2. So once again, you're learning to work among different tables and sections of the tables. You will get your answer, and doing it through practice. Okay? Let's jump to another. There's a whole bunch here. I thought this was an interesting question, and this is in that category of, I have not seen a question like this in a long time, just because of the location that they choose to answer it. So the question is, it says here in the New York State record, okay? So we're talking the geologic record now. New York State rock record. There is no bedrock from the Permian period. Now, that's not something you've memorized, the Permian period, no, but we do have a chart to go by, right? The information is given to you. So, New York State rock record, we have the Permian. They're saying there's none of that in New York. Then they go on and ask, what 2 other entire geologic periods have no sediment or bedrock in the New York State rock record? So, we're missing the Permian, and they're saying we're missing 2 others. So, they give a bunch of names here, but without further ado, right, let's get to the table. Here we go. Okay, so here's our geologic history now. This often is put together open like a book in your table. I've seen it a couple of ways. So here I have it on 2 pages. But in any case, what we're looking for now is let's first find this Permian. And let's see what we got here, okay? So you might be looking here, important events, fossils. You work your way over life, epic period, and so on. In any case, find that Permian. Come down here, look at the names, and there you find Permian. So we're trying to figure out how is it not in New York. Well, what gives us that? We're starting to read. We don't see anything here. But if you come over to this record, this column, I mean, right here, which is very rarely asked about, you do see a gap. You do see an empty space for the Permian. If you look around all these other periods, these geologic periods, epochs, or eras, we see streaks of lines meaning that something was there. And if you look at the top, that's the New York record. It says sediment, bedrock, right? So technically, you're in the New York record, just like the question asked, the New York rock record. And they're saying there's a gap here. There's nothing. And there it is. Whereas we have just about everywhere else some kind of rock. So we look and look until we get to up here, we have gaps again. Okay, do you see that? These are halfways, but we're looking for which 2 geologic periods. And don't forget, periods. We're not in eras, we're in periods. So which 2 periods? So we have Permian as a blank. Then we go up here. There's a blank, there's another one for these odd sounding names, the Neogene and the Paleogene. Okay, this is the rise of the mammal time. Okay, the dinosaurs have already been knocked out right about here, about 65 million years ago, and we have the rise of the modern mammals. Okay, so in this, for some reason, in this grouping here, these 2, you're blanked out. So let's go to the answers. There, first one, Cretaceous. No, that's the dinosaur period. We have sediment. Okay, but there's Paleogene, there it is. Paleogene, Neogene. Those are the 2, and that is our answer. But if you weren't familiar with, working around the table, you might have missed this one. And I asked it because it's very rarely asked anything from this column. So I'm glad that question showed up here. Let's move along. What else we got here? Let's go. All right, let's tell you what. Let's go. Let's jump over here. Let's jump onto this one. Okay, as I mentioned in the introduction, there's lots to do with subduction zones, the layers of Earth, tectonics. So this question is a plate tectonic question. We do have, of course, a table for that, and we've already been looking at it, I'm sure, at some point during the year. And the plate tectonics shows you how the Earth's crust cracked, and you have areas of what they call convergence coming together and areas of divergent going together. So that's some terminology you want to be familiar with. Divergent, convergent, okay? You have the Mid-Atlantic Ridge is divergent, okay? You have here this Peruvian Chile Trench here and South American plate, this Nazca plate, this is convergence zone. And because they're converging, you get another term called subduction. One plate going under the other. So maybe you know all that already. Let's look at the question. All right, base your answers to question 48 to 50, so on and so forth. Your knowledge of science, and now they're saying a cross section shows the boundary between the Juan de Fuca plate and the North American plate. So even without the table at a moment, you could just see they're labeling it for you and they're showing this diagram. The question is, in each of these answers, is they want to know which of these 4 diagrams do the arrows represent the motion of the upper mantle at this plate boundary. So they want to know, what are these plates doing? Well, I can tell you right off the bat, because we have this volcanic activity and then this design here, these plates are coming together, okay? This is a zone of convergence. So we have to look, let's find arrows that match. So in the first one we have, it looks like 2 arrows going leftward, not it. Number 2, 2 arrows going to the right, that's not going to work either. Number 3, arrows going apart, that's like a pure divergence zone. Not going to work. We're not going to get this volcanic activity and this subduction of this plate. This is your correct answer. We have this oceanic crust on the mantle going this way, continental crust right above the mantle going this way. So we hence have volcanoes forming, mountain building, and we also have this crust going down, subducting as they call it. This eventually, as it gets further down into the mantle, it'll start to melt, forming more magma. All right, so basically that's number 4 is your answer here, okay? And we could also answer 49. It says compared to the crust of the North American plate. Okay, this one here. The crust of the Juan de Fuca plate is what? Well, usually any plate going under another, subducting, is going to be more dense. The denser plate goes down. So we have the answer here. We could look immediately for what are the answers with more dense. Not less, but more. So we have number 2 and number 4. We have a denser plate subducting. The question is it thicker or thinner? Well, usually those crusts, these plates that are below the ocean, they're going to be thinner. And you even tell from the diagram, I mean, look at that. It's about 1/5 of the size of this plate here. It's 1/5 just by looking at it. So your answer is going to be 4. It's a thinner plate, but hence more dense since it's sinking underneath. So hence plate tectonics in action. Plate subducting. And volcanic formation. All right, let's find another one I have for you. So they give here this particular question. It may look a little bit like a nightmare, but here you're on page 5, early on in the exam, and boom, here comes this whole multi-layered question. And it says, this is a cross section and represents a bedrock structure of a section of the Earth's crust. Letters A through H represent rock units. Okay, so these for individual specific layers are identified. Line XY represents a fault. So you can see right there, XY, your fault line. Rock layers have not been overturned. That's important information. Now, just to go back a minute, as you can see here how the layers sort of supersede one another, we have something in earth science called horizontality. Horizontality, okay? So that basically means that the science principle of that means the earth layers form horizontally. If you're at the bottom of a seabed or what have you, sediment is collecting over the millennium, it's building up horizontally. So here that's what we have, and we also have a key to the right of the question. We're saying igneous rock, and we have contact metamorphism. So let's take a look at what we have here. Now this here, this is the intrusion. So when you see this is usually also known as an igneous intrusion. And it looks to me like this came along after some of these layers were in place already, right? And when you see diagrams with these intrusions, most likely it'll be moving at some semi-vertical angle. It won't necessarily be horizontal. It can be, but most likely there is an angle. So that's letter A. As for these lines here, these look like a comb on the outside, contact metamorphism. The question really doesn't ask about it, but why, just in case while we're here, that means that the heat from this intrusion is actually, that contact is causing a metamorphic effect on the layers in direct contact with the intrusion, okay? So that's a form of heat metamorphism, although the question will not be asking you that. All right, so anyway, what is the question? It wants to know, when did faulting along XY occur? When did you get this line here? Now keep in mind, a fault could basically just mean you have layers like this, and let's say my fingers actually represent different layering and we're all together here, and suddenly there's this shifting, okay, in either direction. That a fault has now occurred, and it's in the geologic record, just like here. This is like a record of time in these layers. Anyway, once again, when did it occur? So let's go to our first answer. It says after the intrusion of layer A. Well, looks to me like that's completely a solid intrusion, unbroken. The line is really disappears almost behind it, you might say. So we can't say that. No, it didn't happen after. So this intrusion happened after that fault. Number one. Okay. Second answer.
Did the faulting occur after deposition of layers B, C, and D? So we look up here. Okay, so B, C, D. Here's D, here's C, here's B. Well, frankly, the X is determination of this fault line ends at C. C accumulates above, and then B above that. So we can't use answer 2. All right, because this came after the fault. We go to number 3. After formation of units E and F. So where's E and F? Here we go, right here. E and F, they are faulted, they've been affected. So definitely can be after that. Let's just check number 4. Before formation of units G and H. Well, guess what? G and H are also faulted. So it didn't happen before. So 3 is our best answer. After formation of EF, just as G as well. And there's the fault. Okay, so 3 is your correct answer. Okay, moving on to another sample. Let's skip around a little bit here. I'm going to jump to a different topic. Just give you an idea. You probably have heard of the Foucault pendulum. The Foucault pendulum is a fascinating little device. It's basically just a large cable swinging from connected to a roof with a heavy ball at the bottom. And this could be lengthy. In this case of the diagram, they have one that's 200 feet long. Okay, it could be much shorter, 50 feet, even 20 feet to work. But let's get back to the question, see what they're asking us. Okay, so they always, as usual, open up. Base your answers on these questions based on your knowledge of earth science. Okay, diagram A represents a Foucault pendulum set up at a particular location on Earth. Okay, now that could be in a museum, in a building, anywhere, in a gymnasium. Okay, the line on the floor marked 0 is the path of the pendulum when it's first set in motion. So there you can see we have a 0 line basically cutting across this circular floor right here. Okay, then it says diagram B represents curving of planetary winds. All right, this is another part of the question. I want to work on this part A first, the Foucault pendulum. Okay, so what is the given? Diagram A, Foucault pendulum. They're showing here's the swing. Okay, the wire, the ball, it's a steel ball. There's the 0 line, and apparently, as you can see, as it's moving, we've developed a new set of lines here up to 8 hours. Okay, well anyway, what's the question asked? The apparent shift in direction of swing of a Foucault pendulum and the curving of winds by the Coriolis effect are both evidence of Earth's. Okay, so this you were to learn in just the basic lessons that is Earth's rotation. It has nothing to do with the shape. Tilt is something else, okay? Revolution, that is going around the sun. It would not affect this. But the rotation is directly, evidence is directly seen of rotation through the Foucault pendulum, just as you have the night and day, and so on and so forth. If the question asks something about the seasons of the Earth, the 4 separate seasons that you may experience, or various seasons, then you're talking about revolution. If they're talking about constellations in the sky, when you see certain ones during one part of the year and not another, that also is revolution. But rotation is specific to hit the Foucault pendulum, day and night, things like that. Okay, well anyway, that's our answer, rotation of the Earth. Then in 46, question 46, they ask another particular question. They want to ask you about the shift of the path of the pendulum. It's shown at 2-hour intervals for the first 8 hours of pendulum motion. So remember, this is a non-stop process. This will continue to go so long as this device is here and the Earth is turning. But in any case, it went from 0 to 8, so we have an 8-hour interval here of pendulum motion. During the 8 hours, the path was displaced 60 degrees from where it started. So they're telling you from 0 to 8 is basically 60 degrees of a 360 circle, right? They want to know, though, the question they're asking is how many degrees did the path of the pendulum change per hour? So really all you have is a math problem here. That's all it's telling us. How many degrees did it change in 1 hour? Well, they told us the given is 60 degrees from where it started. We have 8 hours. It went 60 degrees, so you're basically just dividing 8 into 60. That's it. That's all you have to know how to do. If you punch it in or write on your scrap paper, you're going to get this first answer, 7.5 degrees per hour. Basic math problem. In finality, the last part of the question says, we flip over here, question 47, it says in diagram B, what are the names of the planetary wind belts formed by the deflected winds shown in the northern and southern hemisphere? Let's go back a second. So they're giving us a diagram saying the Coriolis effect on planetary winds, and winds are curving also because of rotation. Our global wind currents curve. Notice the range they give us. We're at the equator. Okay? And they also give us a key. It's just a dotted line says original direction of wind here. Deflected path of wind there. And notice the arrows are pointing to the equator, right? So Coriolis effect is deflecting the winds, okay, and then going, they seem to be coming together, don't they? And we're at the equator. So if they're asking you, at the equator, what will be the name of these winds that are being deflected? We do have our reference table. Let's find, there's a section on planetary winds, and here it is, page 14 of your reference table. And if we take a quick glance, we have names here. We have a polar front jet stream, we have polar front, we have subtropical jet streams, there's X's marking who's who. But anyway, we're dealing with the diagram here at the equator, right? And these arrows coming in, see these? Those match those arrows right there. And the only thing we have for a name are right here. We have these names. We have a northeast wind and a southeast wind. That's what we have. Let's turn to the answers. And right there, let's talk. They give us by hemisphere, okay? They want to know what are the names of the wind belts by hemisphere. So in the northern hemisphere, well, we're not going to get southeast winds, are we? So we can skip that one. Number 2, in the northern hemisphere, we have northeast winds, and that matches NE here on the diagram. In the southern, we have southeast winds, SE, that matches that one. 2 is your answer. The others you can see are wrong. Northern having southwest winds, southern with northwest. This is not in your diagram, it's not there. So really, you're focusing right on number 2 here. Okay, also you realize how the table is critical. You're getting your answers, you're not sure, let's not guess. You have your tables, your reference tables, find that section and make the answer. Okay.